Hey everybody, it's Brian here with another SPSS video. Today I'm going to show you how to do a one-way chi-square analysis in SPSS. We're actually learning about two different types of one-way chi-square. We have the equiprobable and the non-equiprobable versions. So let's start with equiprobable. So in a chi-square analysis, we're looking at a nominal variable. We're just seeing how people are sorted into different categories. And in the case of an equiprobable chi-square, we're looking to see if the categories are equally distributed among our participants, or whether there's some deviation from an equiprobable distribution that makes us think that this might be happening at the population level. So I have our Halloween data set open here. We're going to work with this scary, weird other variable. Let's learn more about that. If we go to the variable view, that variable, its type of costume that people dressed in. And then under the values here, we can see people's costumes have been sorted into these three categories. They're either scary, weird, or other, coded as a 1, 2, or 3. When you're working with nominal variables like this, it can be really helpful in the data view to go to the view menu and just check value labels. And that way we can see, oh, person number 1's costume was scary, person number 2 was weird, and so on like that. It's just a convenience. It doesn't affect our analysis, but a way to sort of get a better handle on your data from the data view here. So to do the one-way equiprobable chi-square, we're going to see if the 50 people that we have in this data file, if people's costume types are distributed equally among these three different categories. So we go to Analyze. It's a non-parametric test. And we prefer the legacy dialog. So we're going to choose chi-square here. And we find our type of costume variable, pull it over. And all the defaults here are set for an equiprobable chi-square. So we can get that set up there and just choose OK. And then here's our outcome. Our first table shows us the descriptives we see for each of these three categories, how many people actually are sorted into these categories. Here's the expected value. If we had a truly equal distribution, we'd have 16.7 people in each of these three categories of our 50 individuals. And then here is the result of our hypothesis test. This is our chi-square obtained, 15.88 with degrees of freedom 2. And this sig value, this p-value of very small, is showing us that this is significant. So that we can say at a population level that the people's costumes are not equally distributed among these three categories. We should be doing post hoc tests here. We should be doing standardized residuals, which unfortunately for a one-way chi-square, SPSS doesn't do for us. It does help us along. It gives us a residual value, but not a standardized residual. So this is basically the difference between our observed and expected, which is the numerator of the standardized residual. So all we need to do to turn this residual into the standardized residual is divide this value by the square root of n, which is also given to us. And then what we're looking for with those standardized residuals is an absolute value of 2 or greater. And then we know that that category is contributing significantly to this overall chi-square. And I've done this on a separate sheet of paper, and I've learned that the weird category, not surprisingly, is not a significant contributor. But there are more people in the scary, significantly more people in the scary condition, and significantly fewer people in the other condition than we would expect from an equiprobable distribution. So that's the one-way equiprobable version of chi-square. Let's look at the non-equiprobable. And this is a circumstance where you don't expect your people to be equally distributed. Instead, you're trying to see if your sample data match some sort of predefined non-equiprobable distribution. So for that, we're going to go to a different variable. In our variable view, we have this political variable. Again, we're looking at people's costumes, and we have two types of costumes. People are either a political or non-political themed costume. So 0 is our non-political, and 1 is our political costume. So based on my analysis from previous years, I've determined that in general, about 80% of the costumes are non-political and about 20% are political. And so now that it's an election year, I'm wondering if the data that I've gathered here in an election year are significantly different from that sort of baseline 80-20% distribution. So I'm not looking for an equal distribution. I'm not looking for a 50-50 split. Instead, I'm comparing my sample data to this 80-20 split that I am expecting from my previous research. So to do that, I go to the same menu, Analyze Non-Parametric Tests, Legacy Dialogues, chi-square. Get rid of this here. I'm going to pull over my political, non-political, and here under expected values, this is where I can put in different values. So it's really important to have things lined up and do a little bit of planning here, because the order that I enter the values is going to be super important. Notice that the non-political, the one that I think is going to be 80%, is listed as a lower value. That's coded as a 0. So I want to put that in first. So I think that's going to be 80%. And then the next one is going to be the 20%. So let's talk about this for a second. It doesn't really matter. I think of this in percentages, which is why I do 80 and 20. You could do 8 and 2. All that matters is the sum of these is working out to be what you think. So however you think of this best. Again, for me, percentages sort of make the most sense. And if you had more than 2 categories, you just keep entering values. You do need to have as many values entered as you have categories to analyze. It's really just the ratio of the total of these values that's important, not the numbers themselves that you enter. So now that we have our variable set up, we have our values of 80-20 split that we're going to compare them to. We can go ahead and choose OK. And so here we see 33 non-political costumes and 17 political costumes. If we had a nice 80-20 split, we would expect 40 and 10 of our 50 individuals. So we are getting fewer non-political and more political costumes. And then here's our chi-square, 6.125, degrees of freedom 1. And this p-value, less than 0.05, says, yes, this is actually significantly different from our 80-20 split that we were comparing it to. We don't really need to do the standardized residuals with only 2 categories, but we could do that using the same way we already talked about, taking this residual value, which is the numerator of the standardized residual, and divided by the square root of n for that given row. And we would see that both of these categories are contributing significantly to the overall chi-square value. And so we would say that we have significantly fewer non-political costumes and significantly more political costumes during this election year than we have found in our previous data collections. So there it is, 2 types of one-way chi-square in SPSS. So thanks for tuning in, and I'll see you in a future video.